In this lesson we will review linear and quadratic functions and just looking at all the characteristics we can use for each of them. So characterize the function using a palette, and I just named this the palette just because it has all the characteristics, and then if you have all of these available you can use whichever one is the most efficient for solving any problem. So the y-intercept, that's when the x value is 0, so we see the y-intercept is 0, 2. The x-intercept is when the y value is 0. And then we can solve for x, minus 2. Multiply by negative 2, and we get 4. So the x-intercept is 4, 0. We can use a table if we wanted to find more points. Let's try negative 2 and 2. Substitute that in here and we get a 1 plus 2 is 3. Here we get a negative 1 plus 2 is 1. And all of these are helping us graph. So we know 0, 2 is the y-intercept, 4, 0 is the x-intercept, and we also have negative 2, 3, and we have 2, 1. So all the points should be on the same line. If not, then there's a mistake. Now point slope is what we would use if we don't have the equation already. So what if we were given these 2 points, and so if we are asked to make a palette, then we will have to create 2 points to show how the point slope formula works. The slope is y2 minus y1, x2 minus x1. Here we'll have, it doesn't matter if we call this y2 or y1, so we can say 3 minus 1 for the y values, and then negative 2 minus 2. So that gives us 2 over negative 4, which is negative 1/2. Then with that we can use this, y minus y1, x minus x1. That's the point slope formula, and we just substitute a y value. We can use this y value or that y value. Let's use this one, 3. The slope we just found, and then we have the x value of negative 2. That's plus, so that'll be a minus 1. Add 3, and we get plus 2, and that's what we started with, so it just shows how everything is connected. And pause the video, do the same thing for this equation. Alright, so the y-intercept is when the x is 0. We can just leave it in whatever form it's in. We don't have to put the, we don't have to isolate the y. So there's the y-intercept. The x-intercept is when the y value is 0. And we would say 4/3, 0 for the coordinates. If we're going to make a table, then we should get the y by itself. So that would be, if we subtract 3x, then we get this, and know that that is the slope. And there's the y-intercept. So if we were going to make a table, we could do this. If we substitute a 1, we get 1. If we substitute a 2, we get negative 6 plus 4, negative 2. So 1, 1, here we have 0, 4, and 4/3 over 0, so over 4/3 down 0, and that's going to be right there. That's lining up. We have over 2 down 2. Then we can do point slope. And what if we were given 1, 1, and 2, negative 2? So we could find the slope with 1 minus negative 2, 1 minus 2. So there'll be 3 over negative 1, negative 3. Then we use y minus y1m, x minus x1, and y1, let's just say that it is 1. The slope is negative 3, and then the x value would be 1. And so we get the same equation. Then we could use the palette just for, if we just knew 2 points, then we can still talk about all these other characteristics. But we would have to start over here at point slope. So why don't you pause the video, start with point slope, and then work backwards and fill everything else out in the palette. Alright, so the slope is going to be, pause the video and try that one. The slope is going to be 3 minus 1 and 2 minus 6. Then we have the point slope formula, and we need a y value. Let's use 3. A slope, we just found the slope, and the x value. Add 3. Then we can go back and find everything else. So if the equation is this, then we put a 0 in for x, and we can see the y-intercept is 4. The x-intercept is when the y is 0. So we'll subtract 4. Multiply both sides by negative 2. And then let's put those on the graph. And We could also use the table to find more points. Alright, so that's linear equations, and now let's look at quadratics. And we'll do the same thing. We just have some different strategies with a quadratic. And now we have some options for finding the x-intercept. We could isolate x, we can factor, or we can use the quadratic formula. We also can talk about the vertex, and we'll also look at the domain and range. So y-intercept, we still just make the x 0. And we make the y 0 for the x-intercept. Alright, if we're going to isolate, we can't isolate as it is. We have to complete the square. And that would look like this. We're going to add some number and subtract some number to complete the square. So we take half of this and square it. So we get 25 over 4. We'll add 25 over 4 and subtract it. So this equals 0. And if we take the original equation and add 0 to it, it's still the same equation. That's why we have to subtract it. If we then factor this part, that factors as x plus 5 over 2 squared. And this is 24 over 4. So we're going to have negative 25 plus 24, and we get negative 1/4. These two combine to get that. And then we can isolate. We could add 1/4 to both sides. Then we can square root positive or negative, and we'll have a positive or negative 1/2. We can subtract 1/2. Subtract 5/2. So that's a positive 1/2 minus 5/2. We get negative 2. And if we have a negative 1/2 and a negative 5/2, that'd be negative 6/2. And that's negative 3. Alright, and then we could factor. Here's a way to organize the factoring. We multiply to get the 6, add to get the 5. These multiply to get 6, they add to get 5. So we have x plus 3, x plus 2, and one of them must equal 0. So now we get negative 3 and negative 2. And if we can't factor and we don't want to complete the square, we can use the quadratic formula. Negative b plus or minus square root b squared minus 4ac over 2a. So there's b. B squared minus 4ac 2a. (25 minus 24) So negative 5 plus 1. Then we have negative 5 minus 1. And we should get the same answer every time. We also have the vertex is negative b over 2a. That will give us the x value of the vertex. So negative b is negative 5 over 2a. Negative 5 over 2. We need the y value. We could show that up here. Negative 5 over 2. And then substitute that. And we end up with negative 1/4. We can also see a connection to completing the square. This y value is the same as this value, so we see that that's the horizontal shift and the vertical shift. Okay, and then we can graph. We have to go 0, 6. And we also have the negative 3, negative 2. If we go to negative 5 halves, we'll go down 1/4. So there's negative 5 halves, down 1/4. So we can see the vertex there. And we can also talk about the domain and range. The domain is all the x values. So this graph continues going to the left, it continues going to the right. So that will be all real numbers. And the range is all the y values. So we look at the graph. Well, this y value does not have a point on the graph. This y value does not have a point. So it starts at negative 1/4 and then goes to infinity. So the range is negative 1/4 to infinity, including negative 1/4. So we use a bracket. And one more thing, the inside of the radical is called the radicand, and it's also called the discriminant. So we can use the discriminant to determine how many solutions there are and what type they are. If this is 0, then we're going to go plus or minus 0, and we only get one real solution. If we have a positive number in there, then we're going to go plus a positive, minus a positive. We get 2 real solutions, and if we have a negative in here, that'll be 2 imaginary solutions. All right, pause the video and try that one. All right, the y-intercept is still when the x is 0, so we get 5. The x-intercept, we make y 0, and if we're going to complete the square, we can't have a 2 as the leading coefficient, so we can factor that. But we don't worry about the 5. It just sits out there. And now let's rewrite it one more time. So I'm going to add something to inside the parentheses and also subtract something outside. We can divide by 2 and square. That'll give us a 4. By writing a 4 there, we have not just changed the value by 4, we've changed it by 8. So that means subtract 8 out there. And now we factor this as x plus 2 squared minus 3. Combine those, and we can solve for x by isolating x. So add 3 and divide by 2. Square root. And then subtract 2. So we have negative 2 plus or minus radical 3 over 2. And we should write it like this. So multiply numerator and denominator by radical 2. So we get radical 6 over 2. That would be a good way to write it. Okay, factoring. Remember that if we're trying to factor this, we put a 10 here and an 8 there. And when you think of two numbers that multiply to get 10 and add to get 8, and that's not going to happen because we have this radical down here. So we can skip factoring. We'll go to the formula. Negative b squared minus 4ac 2a. Eight times 5 is 40. 4. And then we get 24. So this is 4 times 6. That means we'll take out a 2. 2 radical 6. And we can reduce that. So that will reduce that to a 2. It'll reduce this to a 2. And we get the same solutions as before. Okay, let's do the vertex. Negative b over 2a. Negative 8 over 4. Negative 2. And then we have to find the y value. If you remember the shortcut, instead of substituting that into the function, we can look for the y value. If you complete the square, you can see the y values there of the vertex. We have 1, 2, 3, 4, 5. 0, 5 is the y-intercept, and then these, if we find decimal values of this, in order to graph, we need to know the decimals. So negative 0.775 and negative 3.225. That'll help us graph negative 0.775 and negative 3.225. And the domain is all real numbers. The range starts at the y value of the vertex and goes to infinity. And we'll stop there.